Hello everyone, welcome back to Math Bison. Today we are taking the third episode of our quantitative reasoning session. Alright, hang on and let's have fun with quant. Okay, in this video I'm going to show you, we're going to walk through some quant questions and I will be showing you my thinking process and the key ideas that we must follow. Is like a blueprint on how to go about it so that we can save time and we can maximize our accuracy. In this question, we have, okay, so let's get into explaining what's happening here. You will notice that usually I like to start with labeling the part. There are three parts. We have A, we have B, and C. A, B, C. A, B, C. Just for caution purpose. And what do we do next? We try our basic operation. So we are going to try our addition, subtraction, and what? Multiplication, and even division. So let's try. Here, in this first diagram, if we have 13 plus 8, we're going to have 18. 13 plus 8, we're going to have 21. But this is not 21. 5 plus 3 is 8. It is not 4. 21 plus 7 is 28. Even though it looks it here, I think that we cannot agree with this because it didn't work for the others. Okay, subtraction 13 minus 8, we have 5. There's no 5 here. Then we have 5 minus 3, we have 2. There's no 2 here. 21 minus 7, we have 14. There's no 14 here. But somehow the answers we just got is ringing a bell. It seems like there's something we need to try, which is what? Magic number. Magic numbers. It's a number that's not showing, but it does exist. It does exist. In this case, how come I have 13 minus 8 and I'm having 5? And 5 is so related to 10. In the second diagram, 5 minus 3, I have 2. 2 is so related to 4 in the way that 5 is related to 10. And now we have 21 minus 7, we have 14. 14 is also related in the same way. As a rule, the magic number is what? Is a times 2. So we have 13 minus 8, we have what? 5. Then we have to do 5 times 10. This is 10 that we are looking for. And here, 5 minus 3, we have 2. Then the magic 2 comes to play. 2 times and we have 4. Look at it, that's the 4. And here we have 21 minus 7, we have 14. And 14 times 2 is 28. That is it. In this case, we are using a magic 2. If part A is missing, what do I do? First of all, remember what we said about reverse engineering. If 13 is missing here, and I have a number is missing, minus 8, and I get 5, and 5 times 2 gives me 10, the first thing I should do is reverse engineering. I'll do 10 divided by 2, which is 5. Then I now know that, okay, this number, when I subtract 8 from it, I must have the same number as 5. So what do I now do? The number that's missing, minus 8, should give me 5. So this number, by reverse engineering, if I subtracted 8 from it to get 5, then I should be doing 5 plus 8, which is 13. If 8 is missing, it's the same thing. 13 minus the missing number to give us 5. Then by reverse engineering, 13 minus 5 should give me what? 13 minus 5 should give me 8. Another way to look at it is to say, okay, there's a number, I take it from 13, I get 5. It is not the same number. When you take 5 from 13, you still get that number. So this is the way this is working. So let's take a few exercises. Now, in this exercise, we have, all right, this makes sense. So how do we solve? The first one, if this is missing, we only need to do 27 minus 15, that is 12, 27 plus A minus 15 minus B, then times 2 will give us this. 27 minus 15, okay, that will be 12. Then 12 times 2 should give us 24. So this missing part is 24. Number 2, this part is missing, but I know that if I subtract 5 from this number, if I subtract 5 from this number, I'm supposed to have a number that when I multiply it by 2, I will get a 10. So that number should be what I get when I do 10 divided by 2. I should have 5. So this minus 5 should give me 5. So this side is going to be what? The same number you get when you add 5 and 5. This will give you 10. So this is the number we're looking for. The number is 10. Now, here in number 3, which is the last one for this sample, we're going to have 13 minus a missing number. The answer we get multiplied by 2 and we get a 10. So the answer is what you get when 10 is divided by 2. You have a 5. So this has to be 5. Now, what do? We have to have 13 minus a number to get 5. Then, what is that number? I should have 13 minus a missing number to get 5. I should be having 13 minus 5 to get the missing number. So the missing number is what? 8. So, guys, the number we're looking for here is 8. All right, thank you. So let's go to the next sample. So what are we going to do here, guys? Yes, let's look at how this is working. So following the same system, we try to go with what? The first thing we want to try will be first thing we want to try will be additions, basic operations. We're going to try our addition. We're going to subtract. We're going to divide. We're going to multiply. And in all of this, if nothing works, we do a combo. And we know we can try magic number. We can try squares. We can try what? Square roots, of course. Square roots. And we can try cube roots. Cubes and cube roots. Whatever works. But logically, let's start from simple to complex. So as I can see, 6, 12, there's already a relationship. 6 times 2 gives us 12. Or 12 divided by 6 gives us 2. 6 times 2 gives us 12. 12 divided by 2 gives us 6. And we are seeing that, well, somehow even 6 times 12 gives 72. And 6 plus 12, so a combo now. 6 plus 12 gives us 18. So if we do 6 times 12 multiplication, the answer will land here. But if we do 6 plus 12, we do 6 plus 12, the answer will land us here. So what are we doing? 6 times 12 is 72. And 6 plus 12 equals what? 18. Okay. If we label this part as A, B, C, D, I know that we can set the rules and say A times B will always give us C, and A plus B will give us D. However, what about if here is missing, guys? If you have 6 missing, if 6 times 12 gives us 72, by reverse engineering, 72 divided by 12 should give us 6. And if 12 is missing, 72 divided by 6 should give us 12. And here, if 6 is missing here, we can do 18 minus 12 by reverse engineering of this, we get 6. And if 12 is missing here, we also do 18 minus 6 and we get a 12. So let's see if we can take a few samples. All right, for us to do this, guys, we need to just look at quickly. This is a very simple one. We know that 8 times 3 will give us 24, and 8 plus 3 should give us this plus this should give us this. So here is going to give us what? 11. And 5 times this will give us 25. So it means that 25 divided by the 5 should give us this. So 25 divided by 5 should give us 5. Here is 5, guys. And in this case, the first part is missing. And how do we get this? It's usually going to be 3 divided by 6. Pay attention, guys. You see that in this case, 3 divided by 6. We didn't say 6 divided by 3. The direction is important. We did 3 divided by 6 from what we did here. It is this one, part C, that has to be divided by part B. So it's going to be C over B. It is not commutative. You cannot swap them. So you have 3 divided by 6, which is half. So here is half, because half times 6 will give us this. And half plus this will give us this. Here we have 12 times 8, which is 96. And here we're going to have 96. 96. 12 times 8. 96. So this is the second sample that we want to talk about. Now let's try the third sample, which is the final one. Interesting. How do we solve this? Let's try our basic operations. What's making sense? We look at the diagram itself. Is it telling us anything? The box is saying that, oh, whatever operation we're going to do, we have to use all of the numbers inside the box. Then it's going to give us an answer that will be outside the box. So this is the first clue we can get. So how do we now do? 1 plus 2 plus 3. 1 plus 2, 3 plus 3. Oh, 6 plus 4, 10. Wow, looks like it. But is it what it is? No, we can't just conclude yet. 5 plus 2 is 7. 7 plus 3 is 10. 10 plus 8 is 18. This is not 18, guys. There's an issue. 4 plus 7 is 11. Plus 6 is 17. Plus 9 is 26. This is not 26. So that rule did not work. So if we try multiplications, a lot of time when you have a number presented in grids like this, one of the things you want to really try is to check cross multiplications. Cross multiplication is a possibility. It's a new trick we are learning today. Because if you say 1 plus 2 gives us 3, yes, but 5 plus 2 does not give us 3, 4 plus 7 does not give us 6. Then if you look at it very well, 1 plus 3 gives us 4, but 5 plus 3 even give us 8, but 4 plus 6 does not give us 9. It's a problem. See how this works for just 2 parts and it does not work for the third. We need something that works for the 3 of them. But from knowledge of past, I know that we can also try something like this, something that works. We can do this and do this. We can do this and do this. Do this and do this, and see what you get from it. So we can be looking at, okay, let's have 1 times 4. 1 times 4 equals what? 4. 3 times 2. 3 times 2 equals 6. Add together, you have 10. Let's see if it works here. 8 times 5 equals 40. 3 times 2 equals 6. Add together, guys. You have 46. That works. But let's see if it works for the third one. 9 times 4 is 36. And 6 times 7 is 42. 6 times 7 is 42. And when you add this together, you have 78. This works, guys. But the next question is, what if and if any part of this is missing? So the first thing you really want to do, if one is missing, for example, such that we now have a number is missing. If I multiply it by 4, I'll get 4. And I don't know I'm going to get 4 anyway, because here it's not easy to figure out whether you get 4 or not. But what is obvious is that 3 times 2 will be there. 3 times 2 will be what? Will be what? 6. And you already know that the answer is outside. So I can just do 6 minus, 10 minus 6 to get me the answer I must get when I multiply this part. What answer should I get? It is only going to be achieved by looking at what? 10 minus this, the product of this. So which is 4 now. What if 4 is missing? If 4 is missing, it's the same thing. You need to start with 10. Hold on. 4. Now, if 4 is missing, we're going to do 1 times this missing number equals 4. And what will I do? I don't know if this is even going to be equal to 4. For me to get this first, I need to do 10 minus what? The product of this, which is 6. And I'm going to have 4. So I now know that, okay, 1 times this should give me 4. So this work should be 4 divided by 1 by reverse engineering, which is still going to be 4. The next one is, what if 3 is missing? It's the same step we're going to do. We're going to do, start with, if 3 is missing, square missing number times 2 should give me what? I don't know this, but I can know this by saying 10 minus 6, 10 minus 4, 10 minus 4, and you get what? 6. So here is 6. Now that I know that that place is 6, then I can figure out what's going to be here. If this times 2 gives me 6, then that number that's missing is 6 divided by 2, which is 3. I found the 3 that was missing. Okay. Having said that, let's take some exercises. And 9. What is outside? So let's start with this first one. We're going to have 8 and 9 multiplying 6 and 3, so that we have 9 times 8, that's 72, and we have 6 times 3, which is 18, and we have addition of this, we have 10, and we have 9, 90. So here should be 90. Okay, talking about this part, okay, I'll come back to this. So in this case, I'm going to have 5 times 11, then 12 times this. So the first thing I really want to do is to know the product of this and this, which is 55. Then I'm going to do 5 times 11 is 55. Then 115 minus 55. This is going to be 60, guys. So once you have 60, we know that this missing number times 12 must give us 60. So that missing number is going to be the reverse engineering of 60 times 12, which is 60 divided by 12, which is 5. Here, guys, here should be 5. The next one is a 9 times 0 and a 4 times a particular number that will give us, and the sum will give us 16. So all we can do here is to say 9 times 0, and you have 0. But we know that 16 minus 0, 16 minus 0 should give us what? 16. So it means that 4 times this number times 4 should give us 16, which is going to be 16 divided by 4 by reverse engineering. We're going to have 4. So that missing number is 4 too. The missing number here is 4. In this question, we're going to also be looking at how to get the number outside. So I'm going to do the arrows again goes this way, and we have 1 over 3 times 6. We're going to have 2, 3 here, 1, 3 here, 2. And 1 over 5 times 10 is also 2. Now, if you multiply this together, sorry, you're adding. If you add it together, you have 4. 2 plus 2 equals 4. Thank you. We've come to the end of the video today. I hope you had a nice time and enjoyed the video. Support the channel, share with families and friends. Let's have more views and encourage us to bring you more interesting videos. Bye bye. See you next time.